Okay, let's get started. Any you want to talk about what they were able to do or with or where they got to?
Oh yeah. I decided to change over to using what you were using and took a look at like the PyTorch forecasting thing, but I'm not sure I completely understand it or how far I've got. Um, I can show my notebook here and perhaps you could help me with some of my questions about it. You probably know more about it.
Yeah, I was try because I was struggling with it myself too, and slowly figured out that I had to reduce the testing stuff to only be the decoder length, which is very limited, and blah blah blah. So anyway, actually
Yeah.
good. Go ahead.
Yeah. Um, I don't think I'm having the problems that you were having. Like I'm not running out of memory or anything, but it's just the results I'm getting aren't the best, maybe. Yeah, so like this
Mm.
here is running. This is running it in Collab. So I've prepared like a data set based on the Kaggle competition data set, but just like resampled so that it has every minute and it sort of fills in the blanks and adds a few extra fields in. But yeah, so within Collab, so the first thing I did obviously is like the pip install
Oh,
of
so
PyTorch
did you fill
forecasting.
in the missing time steps, Steve?
Yeah, so like I fill them in. So the missing time steps, I can't remember what to do. So if the closing price is missing, I just take the previous closing price and then I set like the volume and stuff to 0 and just set the other ones to the closing price as well. And the target, because I have that other code, I can calculate the targets. So I can fill in the missing minutes with the target values from that. So, but yeah, so like here within Colab, yeah, so like I do like the PyTorch install, but it seems to be that this PyTorch forecasting thing is maybe slightly out of date in the packages that it uses. So like after I've done that, then I need to restart the notebook again to get it. I think it's like bringing earlier versions of pandas and NumPy in. So that was a bit strange. Um, yeah, so like this here is just getting like the normal asset data and then like my custom data file. And then I had to do some stuff with it. So yeah, like the PyTorch forecasting thing, it wants to have like its own time index where the time index
Right.
just increases by 1 for each one. So like
Right.
I just divide the competition's timestamp by 60 to get it like down to yeah like an increasing integer number. Um, yeah, so like these extra fields are just that's the stuff I was like showing you last week about signing costs on the date and time. Um, yeah, so like then it was like into the creating like this thing, their data set for the
Right.
PyTorch forecasting one. Um, so here, so this data here, so public data stamp is the timestamp at which the public competition data starts at. So here I'm taking as the training data all the data before the public test set, and then I'm subtracting. Yeah, so like here I'm using the timestamp. So like this is in seconds or whatever. And my
Yeah.
prediction,
Yeah. So you're just
yeah,
multiplying by, but your prediction is just for the next
yeah,
second.
yeah. So I'm only predicting
Yeah.
like
See, that's
the one thing.
okay.
Yeah. So I think
That's
I've got.
where I struggled with because I think, I mean, finally, I didn't, I haven't submitted or run it yet, but I think um, looking at the paper itself, they have a case where um, they have one retail competition in which they choose the prediction length to be 30 and the encoder length to be 90. So I was thinking potentially you could go maybe up to 60 on the prediction length and then go on the encoder length to, you have it at 64, maybe up to 128 or something like
Yeah. So
that. But
I wasn't really sure. I only chose like this prediction length of 1 just to deal with how I sort of cope with the data in the actual prediction loop. Yeah, so here, so I think I've got like 64 timestamps going in on the encoder side, and then one prediction coming out. So like, as I say, the training data goes right up to the start of the public test set, but excluding just one set of timestamps. But then they come to like this validation thing. So the validation thing, then it goes right up to the public data timestamp, so, which means my validation data is just all of the training data plus one extra timestamp. So I don't know, does that mean, I don't actually know what it's validating on. Is it just validating on one timestamp every single time? I'm not sure. Or does it validate across the entire training set? So I wasn't really sure what it was validating on.
Yeah, so, see, that's where, to me, what I was doing was keeping the validation set to be, again, after I figured out that I was in any of these techniques, we are severely limited by the decoder length, right? Meaning you can't do the remapping of just letting it rip, and you have to kind of narrow down the prediction thing. So I was at least planning on, and I hadn't submitted it yet, but I had reduced it down to saying, okay, I'm just going to use 2 hours of data, which would mean, 120 minutes of data to predict 1 hour of data, which is 60 minutes of data, or, something like that. So my prediction, which is in this case validation, would be 60. In your case, since your prediction is 1, yeah, the validation is also 1. So I was thinking of predicting for 60 time steps using 120 time steps.
Right. Yeah. So
like where you just because the problem you run into, or at least I was thinking of, is your encoder length also limits how much actually how much data at a time you're using to do the prediction anyway, right? And how much is your encoder length in this case?
I had it 64.
Yeah.
Yeah.
Yeah. So you're using 64 previous time steps to predict one time step.
Yep.
Yeah. But were you able to get it to run, or I was having, obviously.
It runs okay, but yeah, so like here, so I've got it running for like 40 epochs, but just, yeah, so yeah, so like here in the actual temporal fusion thing, so I ran that Optima parameter input finder thing, so it came back saying 3 attention heads was best, so I set that to 3.
But I think the one other suggestion I would have is you should probably, besides increasing the validation size to be more, you probably would be better off increasing, I would think, the hidden size, right? Did it really say 20 was good enough?
Yeah, well, actually one of them came back saying 8, and then the next one said 20.
Wow.
Yeah, so, one other thing I missed was here. Originally, yeah, so I just copied this Stallion one, which is like on some other Kaggle competition. And yeah, like within their time series data set on the, like on the target variable, they're using this group normalizer thing.
Yeah, I tried that. It gave me some errors, so I got rid of it.
Well,
but I think it is needed.
Yeah, well, I'm not sure though. I had it and it works. But what happened then was all of my predictions ended up being 0. So yeah, like I think they'd all been maybe normalized to 0, and I didn't know how to get the actual prediction back. So yeah, so I've turned the target normalization off.
I see. But because one thing, if you go back there, even if you don't use the softmax, which the soft plus, it makes sense at least as I thought about it, to use the target normalizer to be the group normalizer, where the group is the asset ID, because what that does is it normalizes the target depending on the asset, which is something that you had mentioned previously too, right? Which would be a good thing to do, because then if the target that you're predicting is widely different for different coins, then the group normalizer normalizing based on asset ID would work well. I didn't quite get why you would add soft plus, so you can remove soft plus, or you can give it no transformation and give it just groups as asset ID, because I thought that would make sense of, you know what I'm talking about, that it would normalize the target based on the asset. But if you're
Yeah,
getting zeros, that's interesting.
yeah, no, like I think that that would probably be a good thing, but like then when I use the network to predict, I think my targets then are normalized, and I don't know how to unnormalize them. So I don't know how to get the true target value back from the predictions, which is why I've turned it off. But
I see. I see.
yeah, so I'm not sure about that bit. Yeah, so like yeah, when I run it, it seems to run okay, and yeah, so like this is my validation loss, which keeps decreasing, and yeah, like that's okay. But again, then yes, like that was running for, well, I think I'd set it to run for like 40 epochs in this case, but it's stopped after
How
21
long
because
did 40 epochs take?
I don't know, about 15 minutes, something like that.
Oh, okay. So that's not, but again, it's just a single prediction. See, this is the thing that I was
Yeah, but
saying, this method, right?
yeah, so yeah, it didn't
Because
take
if
too
it's
long.
single time step, then, and it takes 15 minutes to do one time step, right? Like if you do 60, which is just even an hour of prediction, right? If a time step is a minute, if on the other hand a time step is a second, then 60 is just 1 minute. So if 1 minute takes 15 minutes to predict, I mean, setting aside that you're getting bad results, but even if it got good results, but if it takes if 1 minute takes 15 minutes, then, you know, you can calculate 3 months of data is going to just kill you.
Yeah, but this is training the network, so the predictions
Ah,
don't take that
that's
long.
true.
Yeah, this is just the training bit.
Ah, that's true.
Um, but yeah, so like that's it trained, and then here it was like sticking through the validation data back into the thing to make some predictions. So you can see here, so I presume the blue line is the training data, and then the blue dot is what the 1 point of validation data would be for this asset for that minute, and then the yellow dot is what my network's predicting. But you can see, like, even so, even though I took the scaling off, a lot of my predictions are really close to zero. So here are the predictions at zero, here very close to zero, here exactly zero, and it always like seems to just sort of predict zero. Um, so yeah, I'm not sure. I'm not sure if it's any good or not. Yeah, so like then this is the actual prediction loop. So this here is like, well, the data here, the decoder data is all of the public test set data. But yeah, so like it just works its way through. So it has a starting, yeah, so whatever that was, 64. So it starts off with 64 minutes of training data, and then it adds on in this loop the end time step, goes through all of the test time steps. So it's like a sliding window across the data. So in each loop, in this case, it'll add one more time step from the test data. And then, yeah, so I've only done it for the first 1,000 time steps because it takes a while. But you can see here, so like the blue curve is the true data, and then the yellow one is my predictions. So you can see basically all it does is predict the sort of wavy line around about zero. And yeah, like with that, it gets like this score here, which should be sort of comparable to what the public test set would get. So it maybe is the best score I've achieved, but I'm not sure if it's any good at all, or is it just because of the fact it's just producing a line around about 0 that is why it got it. So you can see
how long does it take for your the prediction to run?
Oh, that's only about 5 minutes or something. Yeah, but like that was only for like 1,000. I think it to predict the entire public test set over the whole 3 months, it takes about 4 hours, I think. Well, that there's in Google Colab. I presume the speed in Kaggle would be something similar. But yeah. So yeah, like now I've got a trained model. I was wondering, can I take that and put it into Kaggle and see? But in Kaggle as well, the PyTorch forecasting thing's not in, and like obviously you can't pip install it because you can't have internet turned on. So I have created,
that's
like,
the thing I was also wondering about, like whether we can. Is there a way to load it beforehand or something?
Yeah, so I've taken like the WH file. Not sure if I have it here. Yeah, so like I created a public notebook, which you can get. Yeah, this thing, PyTorch forecasting WHL. So it's public, so you can use that. And yeah, like so you just pip install, but from the paths. For whatever reason, it required like an older version of scikit-learn. So yeah, so like that does get it into Kaggle, and then you can use that without the internet being turned on. So, as I say, I don't think my actual sort of notebook itself is much good, and I don't think the results are any good. So I don't think I understand the PyTorch forecasting well enough to yet.
Yeah, part of it is the. Oh, by the way, back to your notebook, I saw. Is it just? I was just looking at what you provided as the other inputs.
What do you mean, these ones? Like,
yeah, and so by the way, the one other comment I had, and I learned this after digging through so I had one comment and a couple of questions. But the comment I had is, the static reals. So yeah, with respect to the weight, the way the weight is used in how I originally added the weight to, I forget where else I had added it, but the way either PyTorch forecasting or the temporal transformer thingy uses weights is different because it multiplies the weights to calculate the target, and that's not what we want. So then I dropped the weight. The static reals, I assume they are not used in any multiplication or any modification other than they're just a number that is static throughout the data. Right. Yeah. So that doesn't matter. Then what did you add as the missing target column? What's in it?
Oh yeah, so like,
is it
obviously in the actual competition data, some timestamps are missing, or some assets have their rows missing at various timestamps, and so yeah, like it was easy enough just to sort of fill in the missing rows. But yeah, like I had to calculate the target, and to calculate the target, it uses those formulas like we'd had before, where it looks back over the whatever the last 3,750 values and whatever works out the sort of the price ratio between the next timestamp and 16 timestamps into the future or whatever. So, but like that's a separate notebook that does that. Yeah, so
you just have a flag indicating whether the values actually missing in the original data.
Yeah. Yeah, so this missing target, when that's set, it means that the target value has been calculated. Whereas like if the target value came out of the original data, that would be 0. Yeah. Oh, one other question I had was in the prediction loop. Yeah, so here's like the line where it's actually using the data to do the prediction, and I get then the predictions back. I wasn't entirely sure what order the predictions came back in. Like it does give me an array of 14 floating point numbers, but I wasn't sure were they ordered by asset or were they ordered, like at each timestamp in the data, and the assets are jumbled about. They're in like a random order, so I wasn't sure. I wasn't entirely sure when these came back. Did they line up with my assets, or did they line up with the order of the rows in the test data or whatever? So I've taken them like as asset data, but yeah, they may not even be right. I may have like all of them jumbled up as well, but I wasn't sure how to figure that one out. I haven't looked at the paper at all for the fusion transformer thing. So
right,
perhaps.
but this one may be a PyTorch forecasting thing than, but I don't know. Yeah, I'm thinking, the order in which it sends it back, because, yeah, that's a very good question. Don't know if I find out as I muddle around the paper and PyTorch forecasting. But that's an excellent question.
Yeah.
That I don't recall off the top of my head because I haven't even gotten to where it worked and gave me the results. One other question on that same cell is, do you provide all of the additional covariate data to the prediction loop?
Yeah. Yeah. So like,
and where do you do that?
Let's see here. So, yeah. So like data is like the full data frame of all of the data, and then like as I say for the training bed, I'd just sort of cut off and taken the early data. Whereas here, yeah, like now it's using a sliding window, which initially starts with the majority of training data and like one timestamp of test data, and then slides over so it uses 2 timestamps of test data. So yeah. Yeah, like in the actual Kaggle thing, I would have to do something different here because I obviously don't have the full data set, so I'd need to use some.
Yeah, but there you'll have to go and use the API to get the additional data and shove it in here.
Yeah, that's right. Yeah. So.
Yeah, because that's the part that at least in the example he had skipped and just said, "Oh, I'm just lazy. I'm going to do this," but you need to provide all the rest of the data here.
Yeah. Yeah. So as it is, so I've got quite a few questions and not very good results, and I don't really know what I'm doing, but it works and produces me something. But as I say, it all just seems to be close to 0.
Yeah, but besides that, I was at least personally, I felt even going through the paper, and I hadn't gone through the even reading the paper, I couldn't figure it out. Some of the questions I had of, how long should my, it took me, I have been really slow in grasping some very fundamental things in this competition and stuff and using the time series. And so it took me a while to figure out I could not submit or I couldn't get more than few results at a time. Like, in your case, you just reduced it down to one, and I was trying to get a full day's worth, and a full day's worth is just about impossible because it's like 1,440 or even that multiplied by 60 time steps, which is just humongous decoder length, and it took me a while to grasp that that's what was driving. I mean, you guys had pointed it out, and then I narrowed it down, but even a day was too much. So that's why it's kind of interesting that when you narrowed it down to one step is when it got, and I just was trying it. Finally, I broke down to trying it for like 60 steps, but I haven't gotten it set up fully yet. So, and make a long story short, the paper was also quite hard to get through, and I had to actually refer to the GitHub code in order to figure out what they had done and what was the encoder decoder length for some of the data that they were using in the paper. So I think if people are interested, collectively trying to go through the paper, at least for me, would be helpful, because the paper was very challenging to go through as well, compared to so many other papers that, right? So it's kind of interesting because they talk about how all the techniques contribute to the various things, and still pretty dense to me.
Yeah, no, it'd be good to do
Jack,
that.
any luck? Yeah. Oh, by the way, just another comment. Just a minute, Jack, while I remember this, just wanted to make the point that, I tried Deep AR as well because I got frustrated with this, and I said, hey, does Deep AR have any techniques? And I had to give up on Deep AR, and if somebody else has tried it and or has a comment about the issue that I'm highlighting, let me know, because one of the things Deep AR, at the very end of the paper and in a throwaway line, they say something which I was like, oh, thanks for, making me drag through the whole paper. They just say, oh, the issue is we don't tackle in this paper or with this technique any problem that has missing data values. It's just very complicated to how to address that. So we just don't do it. And I'm like, geez, thanks a lot, guys. But it may be as simple as what you did, Steve. If the way to eliminate it could be to just pad or use the same data, but I am skeptical whether that will give good answers, because when I looked at because of all this, I was diving into the data in the last 15 minutes, I think the last 15 time steps in the public data, the last 15 minutes just before the end of 9/20/2021 is all nans. So what would end up happening is we would be padding all 15 minutes with the prior 15 minutes of data. And I just thought that would kind of ruin, if, for example, in your case, Steve, if you're using that to predict, then you're using 15 minutes of exactly identical data to predict the 16th minute. Because when I actually went down, because I was trying to forecast down at the minute level, and so when I looked at it, the last 15 minutes are all nans in the data.
Oh, the targets are all none?
Yeah.
Yeah, that's because of the fact that you can't get the targets for the last 15 minutes. Because you need to have 16
because of the rolling.
ahead. Yeah.
Right.
But, yeah, so no, you can never predict the last 15 targets. But
okay, sorry, Jack, go ahead.
Yeah, so with the PyTorch forecasting, Shrivina's, do you mean you were still having memory issues or long training times?
Yes, not as Steve did, I was still trying to do more than just one. I gradually realized that I had to dramatically shrink it. I haven't tried 30 or 60, which is what I'm down to. And obviously, Steve has demonstrated that having the decoder to be one time step does work. Whatever work means, whether it gives a good result or not, as Steve said, we don't know, but because it seems to be, Steve, even from your orange blue point thing, it seems to be quite a bit away, right?
Yeah, because of the fact my predictions are always pretty much 0.
Yeah.
So it gets it right if the actual value is 0. Other than that, it's wrong.
Yeah, that's true.
It's just like it seems it's an incredibly fast model to train, at least compared with the space-time informer I'm using, which is also a transformer-based model. And so from that point of view, it's quite interesting.
It doesn't take very long to train, but it
at the same time, like,
good results. Yeah.
It's kind of strange. Like Shrivana is running into sort of memory error. Like,
my problem, Jack, is
wondering...
what Steve avoided. I think I'm providing way too much encoder decoder sizes to where it just is completely lost. I do need. I know that I need to drop that down. I reduced the encoder to be only 120 or something, but my decoder, I still was trying to predict. Initially, I was trying to do a single prediction on the entire 3 months. I gave that up. I came down to 1 month, and then I moved to a day, and even a day has too many predictions. So I need to go in the direction of what Steve has done, which is to take like 30 time steps or 10 time steps or something like that. That's the reason I think I'm running out of memory, because I just give way too big decoder and encoder. Because in a transformer, the decoder size and the encoder size does matter in terms of time steps of how much it's trying to. It's the sequence to sequence model, right? So at least from the fact that Steve has gotten it to work, I'm convinced now that that's the reason I run out of memory, is I'm just using way too big decoder size, and I just need to drop it down.
Right. Okay, so so I don't really have any significant improvements to report. So in the past week, I've tried training with different context lengths. So I think the context is something similar to the encoding length that you guys have been talking about. So I've tried a context length of 128 minutes, 64 minutes, 200 minutes, and I have not found sort of any trend, in using the different context lengths. But that might be because I haven't managed to train for many iterations. And then, like, I later realized that the context length is somewhat analogous to the image size in computer vision, which is like you can train at say a context length of 64, but during inference you can change the context length to like a larger number, like 128 or 200. So I found that's quite interesting, because in computer vision sometimes it's quite common, like you train at a smaller size and infer at a larger size. So I also tried doing that for my submissions, but I didn't see any sort of improvements when I increased the context length at inference. And And another thing I am trying currently is that, which is a slightly different kind of training, which is instead of training the model to predict just like a single, to predict the target at a single minute to forecast a single minute. I train it to forecast for 16 minutes. And here, like the training targets, instead of just consisting of the crypto targets, I also train the model to predict the closing prices of the different cryptocurrencies. And I choose 16 because the target is kind of defined in terms of the closing price separated by 60 minutes. And so I would train the model to forecast for the next 60 minutes. And for submission, I will just take the target, the crypto targets in first minute and submit that. So this is kind of what I'm trying at the moment. But I think I've managed to get a submission to work with this as well. And yeah, so I'll probably just spend the remaining time just do more of this kind of training and submitting and see what happens. Yeah.
So have you actually submitted to Kaggle and got a score back?
And not yet.
All right.
Yeah, so in these attention maps, you can see I've tried a context length of 64. And in this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for this example, there are 14 dependent variables, 14 training targets. So in this example, I'm just training for the crypto targets. But most recently in this one, you see there are like 19 axis ticks here because I'm training for 19 targets. Yeah, so one thing I should add is that due to the model size and training time, I cannot include the closing values of all the cryptocurrencies. So I chose only the closing prices of 5 cryptocurrencies. The 5 currencies that have got the largest weight in the evaluation. Yeah. Yeah, the top 5 most weighted currencies. So when I train for more, when I train not just for targets and also the closing prices, the green line shows the training curves. So for example, here you see the mean absolute error, mean squared error, classification loss. I don't really know why like there's such a big difference between the mean absolute error and the mean squared error when I include the closing prices as training targets, because I imagine like when you're taking the mean and also these all these variables, they've been normalized before they're fit in the model. So I'm not sure why there's such a large difference. Maybe it's a lot harder to predict the closing prices. And here are the validation errors and losses. So yeah, again, I haven't got many validation points because of the long training time. So yeah, I'm not sure what to make of these, to be honest. Yep.
Steve, one other, and actually for both of you in a sense, because I think even the spatiotemporal transformer does this. I'm not 100% sure, but the question I had was, I thought that the TFT also gives you the 50, 90 or the percentile confidence intervals. Were you able to get those? And does the spatiotemporal transformer also do that? And were you able to get that, Jack? Or get a plot or look at it in any way?
Sorry, what kind of plots do you mean?
Percentile confidence, like does the spatiotemporal transformer give you that? Like, you know, instead of point forecast, it gives you then the range of intervals that it thinks that the point forecast should fit into. I know that TFT does that, and I was curious whether I didn't see it in the example that Steve and I were following, but I was just wondering whether there's an easy way to get that and whether Steve got it when he did.
So
I think you had it there,
haven't-
Jack, didn't in your test prediction plots there at the top. That does it, yeah, see the yellow area, is that confidence area?
Yeah, I would say that's kind of but I'm not sure if this is what Shrivenness means.
Yeah, the confidence area is what I was asking, but is that the confidence
this is
plot of, and if so, what are the ranges?
you mean these limits?
Yeah, the bottom and the top, yeah.
To be honest, I don't know, because I've not looked at the code for making these plots. They came with the package, but I suspect these would be like, you know, the 5th percentile and the 95th percentile. Yeah.
Yeah, and I was curious whether Steve, did you
So yeah, so this is for the test set.
look at that, and does it like, you know, because that's another way, if all of the coin thing shows between, you know, that the middle of the bound is somewhere near 0.
So this one looks quite good, I see.
Yeah. Yeah, like within the PyTorch forecasting one, you can choose what loss metric it's using. And like the one that it originally had percentiles in it, where it would give you 7 different percentiles or something, I think it was. But I changed it just to do mean squared error. And so I think I lost the percentiles when I changed the loss it was using. But yeah, like certainly like in the original graphs it was giving me, yeah, like similar to like Jack's ones there with like a yellow shaded area showing the confidence zone. But yeah, I don't think
so
I
you
get that
changed the
anymore.
loss to MSE loss?
Yeah.
Okay.
So like in PyTorch forecasting, you are able to use all the variables provided by the competition, including the open, the volume, and the WAP.
Yeah, you can stick everything in.
As independent variables. Right.
Yeah.
Yes.
Okay. Yeah, so it's very interesting.
And a few generated ones too, right? Like for example, Steve is generating the missing, and he's generating the sine and the cosine and that. So you can stick in not only what's given, but also additional features that you generate.
Yeah. Yeah, like with this, with the space-time former, after having looked through the code, I've come to the conclusion that it can only take features derived from the timestamp as the independent variables. So I couldn't include like the other things like open or VWAP as the independent variables. If you look at their toy data sets, the toy data sets they use for their paper. So they will just have date time, and then they will try to make the model predict every other column. And if you look at another one,
Oh,
this one.
interesting. Because
Yes.
both DeepAR and the TFT allow you, in fact, the beauty of TFT, as I understand it, muddling through the paper, and I can't say I've read through the whole thing, I just muddled through pieces of it, is that it actually allows you to include a whole bunch of what they call covariates, right? Like, in fact, if you look at even what Steve had set up, he had it as, static reals, which means that they are not the weight, and I forget what the ID of the coins were static reals, which means because they don't change with time throughout the data set, but you could potentially give things like holidays or even things like weather, which would change with time. So not only can you give real values which are static, you can give real values which change with time, and then you can give categorical values like holidays and stuff which change with time. So that's the beauty of TFT, is it's very, very flexible in all the different kinds of data that you can provide to it. And in fact, his an example are the sine and cosine values, as well as the missing value flag that Steve is using.
Mhm.
The other thing I noticed was within the PyTorch forecasting data set thing, the time series data set, you can specify lags. You can specify which parameters you want to put lags onto and how much lag, although I haven't got around to doing that. Rather than having to sort of do it yourself, it'll take care of
Right.
it.
Mhm.
Yeah, the concept of this time series data set is very much like the Fast AI inspired, because he, even in Fast AI, he does a lot of data manipulation with the data block concept and stuff. So I think, as Steve is pointing out, the data set, data structure of the PyTorch forecasting is, I think, quite handy. But as with Fast AI, which leads me to this other comment, Steve. One thing I noticed, because I was trying to debug some of the problems it was throwing at me, and one thing I noticed is if you post on the PyTorch forecasting GitHub thing, the guy responds. The writer of the library. So you may want to post that question of, hey, when these things come back to, the question you had of, is it based on the order that it has, or is it based on a fixed order that it gets from somewhere, and you might get a response to that.
Yeah, no, that'd be good, because like that was the one thing I found with the PyTorch forecasting thing. There doesn't seem to be many examples out there. There only appears to be 2 examples, which are examples that the guy's created himself. For instance, and like within Kaggle as well, there's only seems to be one notebook that's used it, and it used it about, I don't know, a year and a half, 2 years ago, and it doesn't actually run anymore. I suspect because of upgrades to other libraries and stuff, so I couldn't get it to actually work. But yeah, like even the one that's within Kaggle is very similar to just the example tutorial notebook. So there wasn't that much information out there about how to deal with these problems.
Yeah, no, absolutely. I agree with that totally, because I was, I think he only has, among the deep learning methods, he only has NBeats, one example, and this TFT, another example. And even that is, when I say one example, like you're pointing out, it's just this, whatever the Kaggle data set that he has used, and, one notebook, and nobody else seems to have done anything else with it, or and stuff. So even when I was debugging, some of the errors it was throwing up, there weren't too much to go by, but I did find that, and these aren't recent comments, but I still saw him responding to issues filed on that library. So you might be able to get answer if you put, because that's a very good question, right? I mean, like, yeah, what if you're giving 14 things, in what order does it come back? And you'll have to really otherwise wade through the code or run a bunch of experiments to figure it out instead of just getting the answer.
Yeah.
Given how fast PyTorch forecasting is, maybe you can try increasing the number of layers. I don't know if it's possible, and certainly like the encoding length. So you can see, it's like you can see more of the data, previous data before making a prediction.
Yeah, the notebook itself, like his sample notebook, because it's all very closely linked in with PyTorch Lightning, it integrates the Optima parameter tuner thing. And so like in his notebook, it has an example where you can set up the number of attention heads and like the size of the hidden layer and like the learning rate and stuff. But the one thing it didn't seem to do was vary like the encoding length, which, like as you say, like it's one of the ones that probably be the most important, sort of finding the best encoding length to use. So I'm not sure if the sort of parameter tuner can do that, or do you have to do it manually?
That would have to be, I would think, done manually, because it's part of the data set that you provide as an input to the tuner, right? Because the time series data set works off of a fixed encoder decoder length.
Yeah.
The tuner won't be able to tune that, I don't think.
Yep.
So you'd have to play with it independently. But I would increase the decoder length, or I mean, I am hoping to be able to try later today, tomorrow, like do 30 steps and try with your length was 64, right? Encoder length, Steve?
That's right. Yeah.
So I was thinking maybe 128 encoder length and 30 time steps, so 60 time steps for decoder length, and see whether that does anything. Cool. Any comments or questions, Terence or Yuri?
No, none for me. Just listening in. Thank you.
Okay, yeah, I think when is the deadline? Next week?
Yeah, it's only a couple of days.
It...
I think it must be the end of January. So.
Yeah.
Okay, for 2 days.
So I think there's 2 days left. Yeah, so he got 2 days to find the winning solution.
Yeah, so after the deadline closes, then maybe we can take some time to kind of wade through. At least I'd like to do that, but if people are up for it, then at least pick a couple of papers and go through them. Maybe the spatiotemporal, since Jack has been using it, and then the time former thing. Primarily because the reason I like these two is, and I'm somewhat surprised based on what Jack said, that the spatiotemporal doesn't allow covariance, because that limits it. I think the thing I liked about the TFT was the fact that you can use it for multivariates, which really helps quite a bit. And we can pick one other one. I'm open whether it's NB. The drawback with NB or is that it's a univariate thing, so you have to predict it time series by time series, but it seems to be reasonably popular. The other option is the spatiotemporal thing, and the fourth option is deep AR as well. So maybe we vote for a couple, spend a week each just reading through it and then discussing what we understand or don't understand, because I definitely don't understand a lot of the TFT paper. So
I think there's a new
So
time
one more
series
week.
competition that's come out. So if you feel like, you know, and making use of what you've been working on, I mean, continue using that, like it's an opportunity. But yeah.
What, sorry? What came out, Jack?
I think there's a new time series prediction competition that's come up on Kaggle.
Oh, is there? Yeah.
Yeah, just a few days ago.
All right. Yeah, because at the start of this competition, I didn't know anything about time series predictions. So
Yeah, I was
now I actually know a wee bit.
Yeah, I was thinking of just like, you know, if your code is already quite ready, then you might as well just put the new data through and see what happens. I don't know.
Yeah.
Yeah, at least in my experience, and it may be just because of the novelty of it, but I've struggled with this one a lot more than any of the previous, even language or NLP or, I mean, part of it may just be the complexity and the volume and the intricacies of time series, which I haven't dealt with, but I think it's pretty interesting. Yeah. Let's get to one more week of just focusing on this competition, and then we figure out, maybe go through a couple of papers and then decide on which one to tackle next. Okay, thanks everybody for joining. Good
Cheers.
luck, Steve and Jack, on submission before the competition window closes.
I need it.
Good luck.
We'll see you all next week.
Cheers. See you later.